Hello and welcome to Databricks episode 3 with myself, Harry McClellan. This is the third in the series. So the first episode we looked at some basic functions, displaying data, selecting data, a simple join. Second session was actually loading in data from possibly external sources like CSVs, data lakes, things like that. This session is going to be slightly more complicated. We're going to go back to our functions, but we're going to be using hashes, double joins, with columns, renaming columns, and then functions within functions as well. So if we crack on with the session, most of our sessions start the same. I put the documentation at the top to all the resources that we're going to be using. You can always click these. I think they'll be in the description of the video to get a more in-depth look at these functions, what kind of parameters they accept, some better examples and things like that. There's the pre-setup to these notebooks, which I'm just going to go and run. This is just loading in the data that's saved. Not too worried about this. We covered this off in the previous session. And then it is always good practice to create new data frames from those tables above. So we're not overwriting those source tables. If we need to go back to them or call them again later in the notebook, we can. So let's just get familiar with kind of what data we're actually going to be using today. We've got 3 tables. We have a people table, and I should say this is all fabricated data. None of this is real. Quite simple, some names, ages, job IDs, things like that. We have a job data frame, which is a list of jobs, how much they pay, locations, things like that. And finally, a job history data frame, which looks very similar to the job data frame. It looks like we lost a column, location, but again, job, payment, how often they work, things like that. Okay, so I'm quite familiar with the data that we're going to be using. If we open up our first task, we're going to be using a with column renamed. Now this function pretty much says what it does. It's going to rename an existing column. So we put in the old name, we put in the new name, and we should basically produce a table with a new column. Now I'm going to do something a bit cheeky here. I'm actually going to set the table equal to itself. So this is overwriting itself with this new column rename, which normally we try and avoid. We should make new objects all the time, but I'm just correcting a source table. So our old column here is hourly rate. We're being asked if we can change it to history rate. So if we run this, here we can see history rate, and in the previous one, it was hourly rate. So we renamed that object with history rate. Check we've got that. Yep, quite simple. Rename column, old name, new name. That's all there is. Now task 3 looks like we're being hit with a big wall of text. We'll break it down and go through it slowly. But we're going to be using 2 new functions in this. So we're going to be using a coalesce, which you should be familiar with if you use SQL. And then we're also going to be using a new column function, which just adds a new column to the table. The coalesce, if you don't know what that does, it will basically take the first non-null value that is passed into it. So if we pass it 2 columns, it will scan the first column, take all those values. Anywhere it's got a null, it will move on to the second column, try and take the value from there. So we're going to be using the history rate column because it has a null here. And I can already tell you that in the job data frame, if I can grab it, we're going to be using the hourly rate column from here. So the hourly rate column from job data frame and the history rate column from job history data frame. Which means we need to join the tables together. So I'm not going to dwell on this too much because we should be quite familiar with joining tables together now. So I'm going to take the data frame A, alias it, data frame B, alias it, and the columns I want to join on. So job history, data frame B because of the JH alias, and job, let's just type this in, job data frame alias J. They're going to join on the ID columns. inner join should be acceptable in this scenario. And if we run this and display it, here we go. So here's our two tables joined together. You can already see that we've got the hourly rate for cat cleaner as 19 and then the hourly rate here as null. So we're going to write a new column to fix that. So we've got our tables joined together. I'm going to have a new data frame joined df2. And we're going to use this function with column. So join df2 is going to be equal to join df. And we're going to take this function here. And what this is saying is with column, give me a new column name, or this will actually overwrite an existing column if you put in an existing column's name. But with column, I'm going to put in a new column name. So we'll create a new column, which is called fixed rate. And this here is the definition of that column. So it could be a literal value of the word test, and it would just have test all the way down the table. Or you can do way more complicated things. You can have case statements in here, calculated columns, things like that. So we are going to put another function inside this. So this is where I said functions within functions. And we're going to be using a coalesce. So as you can see in the highlighted bit, it will take the first column, comma, second column, and it's going to be looking for the first non-null value. So if I put in our columns, it's hourly rate, I believe. So we've got history rate and hourly rate, yeah, from our two tables. So depending on which column I put first, it will take those values. So that is important. So if I was to put hourly rate first, it's going to take all of the values from, I think this is from the job data frame first, and then all of the values from their job history data frame second. So if we now run this, see this new column's appeared, fixed rate, and you can see that it's populated our hourly rate 19 and our history rate null is still gone in here as a 19. To prove that it's taking the first non-null value, probably a good idea to swap these around. So if I swap these around, you can see, let's take, for example, see someone who's changed. This one's changed as well. 28, 8. So there you go, it's taking the history rate first because it's populated that with an 8. But for our hourly rate where it's a null, we've taken that 19. So coalesce is working within our new column. We are also being asked if we could select all of the columns from the job history data set. So I'm going to bung on a select at the end. We can use something called .star, which just means basically give me everything. So I'm going to put in a JH was our job history alias. Now I need to also add in fixed rate here because fixed rate wasn't given an alias. I've only defined fixed rate here, which means it's already past the point where we define the alias. So the alias will only give me all of the columns in this table at this point. So I'm going to also add fixed rate here. So if we now run this, here's just the job history stuff with the new fixed rate. Okay, so let's have a look. Yeah, seems like that was the answer we were looking for. Okay, so on to task 4. We're going to be joining multiple data frames. It's probably not as complicated as it's sounding. It is quite simply a join and then another join. PySpark works sequentially, so you can just continue to add on join, and it will just work like that. So can we join the job data frame into the people data frame and then join the job history data frame as well? Yes, we can. So I'm going to open up brackets just so that we can drop things down and make it a bit easier. So we want the people data frame. I'm probably going to have to use some aliases to get all these joins working. And then we want a join of job data frame. Again, we're going to need to use the alias J for this one. I'll put that outside the bracket, that's fine. Job data frame alias is J. How do we join it together? Column. Need that in quotations. Is equal to so the job ID is equal to the job ID. Sorry, is equal to ID from the jobs table. Going to use an inner join. And then I'm going to copy and paste this because I don't want to write all of that again, and we'll just change some of the values. So we're looking now for the job history. And that will be JH, and that will be JH like that. So that is basically a double join. That's all we've done. It's all within this bracket. So we can continue to add stuff. Sometimes you can do things like this, which just means continue on to the next line. But I've put all of this inside a bracket. So this should all join. If I display this, I'm hoping that I've done it right. Cool. So we've got quite a wide table now. So you can scroll it. With basically our people, job, and job history table all joined together. Select one column from each table. So select, again, I'm going to do it with brackets. Let's do P dot first name, I think was one of them. This needs to be in quotations, comma for a new line. J dot, I don't know, job. And what was one of the other columns? Weekly hours. That with an underscore. Okay, there we go. So now we've only got 3 columns, and we've selected one column from each of those tables. Nice. Okay. So yeah, you can put all of this on one line, but I think just breaking things down makes it easier for the reader or the person decoding to kind of see what code's being executed. We're going to move on to a new function now, which I think is the final function in this session, and it is a hash before we go on to the practice. So a hash basically reads everything in that row of data and provides a unique or literal value to that row. So technically anything in the world can have a hash. It will always be unique. You change the letter to a capital, a number, you add in a blank space, it will change the hash value completely. So we can use it to basically identify if things are changing. But how do we add a hash? Well, we basically add a new column like we did above, and then we use the SHA-2 function. And then we pass in here the rows that we want to create a hash of. For this, I'm just going to do star, which means everything. Give me all the columns in that data frame. So I'm just going to do a hash of all of the values in that row. I'm going to steal the code as we do with all of our examples. So it wants us to create a hash of the job data frame. So job data frame with my new column, and I'm calling it row2 SHA. Here's our function, and it's important that we put the data frame in here as well. I think it's giving me all of the columns of this data frame. Okay, so we get this new row, and you can see it's given it this value, which is unique to each row based on the data that's in the row of every column I've selected. Yep, so quite a simple one. All right, so we're going to move on to the final practice of the session. And we're basically going to perform a check on job versus job history to identify which of the records have changed. It's going to suggest that we use the hash function, and then we join the tables together to identify what's changed. Now, there's kind of something cheeky in here, and I'll talk us through how we get around it. So let's steal this because one of them's already been done for us. And let me also, well, we can print it out again and we can basically do job history, job history. And again, we need to change it here in the data frame. If we were to run this as it is, we would get a hash column for this new table, but it would actually be a hash of the columns in our job data frame table. Now there's going to be a mistake in here that we're going to have to point out and go through. So I'm going to write a display on that. And so if we run these two tables, let's take, for example, dog walker, our second row in. ID is 2, job is dog walker, history rate is 23, our weekly hours is 40. Look at the hash, DAD 15. Look at our dog walker here, 86E, it's different. And that's because there's an extra column in this table. So none of these are going to match up because we've got a mismatch of columns and we're taking a hash of all the columns. So there's two ways around this. A, we could select the columns here. Sorry, actually, in our job table, we could select the columns to not include location. Or I could just create a new table, modify job df equals job df. I'm actually going to cheat and use a new function here. Drop, same as select, but does the opposite. And we want to drop location. And then I'm going to take this modified job data frame and input this into the hash instead. Remember to change it in both places. Now, if we run this, you can already see DAD 15, which was what we got in the one below. Okay, so we're almost on track. So we need to join these together and we need to identify what's changed. So I'm going to make a changed data frame is equal to my job data frame, or my hash job data frame dot join. We're going to use a different type of join here, and I can't remember if we covered this in the previous one, but there's no need to specify the columns. If the column names are identical, you can just specify it like that, and it will join them together. And instead of printing out the column twice, it will unify that column. If I stick in a left join here, print out our results. This isn't the best way of doing it. You could write a filter, you could display everything. But what I'm just showing here is that where we have these nulls, it means something hasn't joined. So I can basically tell you that this job must have changed in history, this job must have changed in history, this job must have changed. We could also write an outer join that's going to show everything that doesn't match up from every table. So all of these don't match. And then if I get it from the second table, these guys don't match to this one as well. So that is it. And if we just have a look at the practice answer, yeah, so we're just adding a hash to both of them. Chose to do the drop drop table and join it in, and then just a left join we went with. But yeah, that is it. That concludes it for the session. Hopefully you found that useful and you can take away some of those functions. Again, the documentation's at the top. So if you want to follow those links, there's more advanced versions of those, but they are basically this is kind of just how you use the function. Thank you very much and hope to see you on the next session.